Hi, my name is Ebenezer Safoedu. I'm a business strategy consultant and a data specialist. Welcome to my YouTube channel. Today, I have with me on the Power BI series, Nikola Ilic, a very die-hard Barcelona fan. I hope he's changing his mind by now. Um, Nikola Ilic is one of the Power BI greats around the world, and I'm happy to have him today. We are going to discuss how to reduce your Power BI models. It's one of the key things that you would need as you increase your data set and increase the number of rows that you are analyzing. So I have with me today one of Power BI greats, like I said, Nikola Ilic. He will do his own introduction and then we'll start from there. Hi, Nikola. Welcome.
Hi, Ebenezer. Hi, thanks, and nice to meeting you, and nice to be your guest.
Okay, so Nicola, tell us about yourself so
Yeah,
that we people
sure,
appreciate.
sure. I will just switch to the slide where the key information is there, so I can just quickly walk through. Yeah, so as you said, my name is Nikola Ilic, and I'm originally from Belgrade in Serbia. But for the last more than 5 years, I live in Salzburg, city of Salzburg in Austria. Uh, I'm working as a manager analytics for Avanade, joint venture company from Microsoft and Accenture. Yeah, exactly. And yeah, other than that, yeah, I have many years of experience working with different data products, predominantly Microsoft Data Platform. Started with SQL Server, then continue with analysis services, reporting services, integration services, and most recently with Power BI. Most recently, if you consider last 4 years, 4.5 years as recent with Power BI. Other than that, I'm also data platform MVP and Microsoft certified trainer. You can find me on web. I'm regularly blogging at data-mozart.com. I'm active on LinkedIn and Twitter. So basically that's it. Privately, as you said, I'm a big Barca fan. Uh, not so good to be nowadays, but yeah, I hope that Barca will come back soon, even without Messi. And other than that, also father of two kids. Yeah, that's
Wow.
also. Yeah.
Yeah, I mean, my small engagement with Nicola shows that he's a very big family man, and that's one thing that I've noticed about him. And like he said, he is the founder of datamozart.com, and kindly check them out, especially on Twitter. He's very active. He's always ready to help. And that's why we have him on the show today. He's going to help us in how to reduce our data sets and our Power BI models. And we are hoping to see so much insight that would help us in our journey in serving our customers when we are actually executing projects. So, Nicola, over to you and take us.
Thanks, mate. Thanks. Okay, so let's start. And first, I want to tell you what should you expect today from this presentation. I like to tell stories, so don't expect a normal session today, as I want to tell you a story about a wonderful tool, Power BI. And in my story, you will be a hero, and our enemy is the non-optimal data model size. As in most stories, heroes win in the end. So you will see how to overcome those challenges brought to us by the evil data model and resolve different issues along this road, and finally make your Power BI development a real fairy tale. So
All right.
make yourself comfortable. Yeah, take a seat, grab a coffee or some other refreshment, and we can start our story. So
All right.
I guess all know the story about Titanic.
Uh,
If you don't know, you should watch the movie with Leonardo DiCaprio and Kate Winslet. I mean, you've already watched it, sure. Who hasn't? At least 5 times. But going
Everyone
back
has.
to Titanic, yeah, the Titanic was basically the most powerful, most beautiful, most everything ship of all time. But Titanic's story ended almost before it started. So after only 4 days of journey between Southampton and New York City, uh, Titanic hardly hit one of the icebergs in Atlantic Ocean. And at first look, it didn't look like something that can transform the greatest engineering achievement into a historical tragedy. However, Titanic didn't sink because it hit the tip of this iceberg. The main reason was under the surface in the cold ocean's water, where the largest and strongest part of this iceberg resided. Now you're probably asking yourselves, what is this man talking about? What on earth story of Titanic he has with Power BI? But if we think a little deeper, we can think of Power BI as an iceberg in the cold ocean's water. The tip of this iceberg is your Power BI dashboard or Power BI report itself. I mean, that looks really beautiful. But the real thing is under the surface. So the biggest and strongest part of this iceberg, which provides stability of this visible part. And this part underneath consists of multiple individual but cohesive parts which enable those parts above to stand strong and shine. As I said, there are multiple individual portions down there. If you think for a moment here as a Power BI developer, you will see different concepts, architectures, and techniques that make your Power BI dashboard shine. If you don't understand and apply those concepts on the right, such as data profiling, data modeling, and data shaping in a proper way, your Power BI report will experience the same fate as Titanic. The same applies if you don't spend your time to understand the architectures and techniques on the left. So always keep in mind that all these, but also many more core concepts are what enable your Power BI dashboard to perform in the most optimal way. And therefore, never underestimate the importance of understanding all those invisible things under the surface. Today, we will focus on learning and understanding the VertiPack engine, and how it can help you to make your optimal data model size, but you should also spend your time learning other key concepts that I mentioned here. In the end, as I like to say, everybody can create Power BI reports that work without knowing these underlying concepts at all. But in the end, there is a huge difference between Power BI report that just work and Power BI reports that works in efficient way. So in order to follow the story or watch the movie, you need to have some skills before you start. For example, you can't read book in Chinese if you don't know Chinese. Yeah. So we are talking about prerequisites, and in regard to this session prerequisites, I need to stress a few things. First, I would say this is a 300 level session, which means advanced level. So it assumes that you have some, not just basic, but I would say intermediate knowledge and experience with Power BI and data modeling in general. That being said, I expect from you to have at least basic understanding of relational databases, their structure, in terms of how the data is being stored in the database. Let's call it that way. Of course,
Dimension and tables.
yeah. Of course, yeah, knowledge of Power BI is also necessary to follow along because I will refer to some things related to a Power BI development that I assume, yeah, you are familiar with. So as we agreed that I'm telling you a story, I mean, we didn't agree, but I hope that you're fine with that. I've intentionally avoided calling this part agenda. Instead, let's think of it as the contents of the book. So what's in for you today? We will learn what is VertiPack, how it stores the data, what kind of algorithm VertiPack applies to compress the data, and how we as a Power BI developers can help VertiPack to build an optimal data model for us. Finally, we will need to leave our book on the shelf, pick our toolboxes, go out, get our hands dirty, and dig deep under the hood of Power BI. I want to show you a demo, which was a real-life example and how I managed to reduce Power BI data model by unbelievable 90% just by sticking with a few basic but extremely important rules that we will talk about today.
Okay.
Okay, so here we are. Once upon a time in a far, far away land. I'm just kidding. My story doesn't start like that. My story starts with a simple question. Have you ever wondered what makes Power BI so fast and powerful when it comes to performance? And when I say powerful, I mean that it's able to perform complex calculations over millions or even billions of rows, literally in a blink of an eye.
Yeah.
Maybe you wondered, but yeah, couldn't find the proper answer. Perhaps you were just seeing the tip of this iceberg. So today we will discover what is under the surface, how our data is being stored, compressed, queried, and finally brought back to our report. And once we are done, I hope that you will get a better understanding of the hard work which is happening in the background and appreciate the importance of creating an optimal data model in order to get maximum performance from Power BI engine. So going back to our starting point, what is a VertiPack? Again, you'll need to wait a few more seconds for an answer. Before we come to it, we should mark the line between row store and columnar databases. VertiPack is a columnar database. As you can see in this illustration, columnar databases store and compresses data in a whole different way compared to traditional row store databases. Uh, Columnar databases are usually implemented in large analytical systems as they are optimized for the vertical data scanning. And this means that every column has its own structure and is physically separated from the other columns. Another important distinction in order to understand what is VertiPack is to understand the difference between Formula Engine and Storage Engine. As you can notice in this illustration taken from the book Definitive Guide to DAX from Marco Russo and Alberto Ferrari,
And Alberto?
yeah, Formula Engine accepts the request. So we are talking about this part here. So Formula Engine accepts the request, processes it, generates the query plan, and finally executes it. Storage Engine pulls the data out of the tabular model to satisfy this request issued within the query that is generated by the Formula Engine. Storage Engine can work in two different ways. VertiPack, that's the one thing that it's being used when we are importing data in Power BI. So basically, VertiPack keeps the snapshot of your data in memory, in cache memory. And this data snapshot can be then refreshed from time to time from the original data source. Today, this part of the architecture will be our main focus. Also, let me go back. Direct query is the second possible option here in Storage Engine. Direct query doesn't store any data, so it just forwards the query from Power BI straight to the data source for every single request. We will also talk about direct query today, but without going deep into details.
Okay.
Yeah, so Formula Engine represents the brain of Power BI. And as already mentioned, Formula Engine accepts the query. And since it's smart and able to understand DAX and MDX, by the way, but it is out of the scope of this presentation, it translates DAX into a specific query plan. And that query plan consists of different physical operations that need to be executed in order to get our results back. Those physical operations can be joins between multiple tables, aggregations, filtering conditions, stuff like that. It's important to know that Formula Engine works in a single-threaded way, which means that requests to Storage Engine are always being sent sequentially. So let's go and reiterate once more through the whole process that is happening within the Formula Engine of the VertiPack. So first, Formula Engine accepts the request, then it will process the request. Next in the line is to generate the plan for this request, and finally, it executes the generated query. Once the query has been generated and executed by the Formula Engine, then Storage Engine jumps into the scene. So Storage Engine physically goes through the data stored within the tabular model, which is VertiPack, or goes directly to a different data source, like SQL Server, for example, if you're using direct query storage mode. With that in mind, we can think of Storage Engine as the muscles of Power BI. When it comes to specifying the storage engine for the table, there are three possible options to choose from: import mode, direct query mode, and dual mode. On the opposite to Formula Engine that doesn't support parallelism, storage engine can work asynchronously. So let's go first and briefly introduce import mode, which is the most common way to store the data when working with Power BI. That said, the import mode is based on VertiPack, and table data is being stored in memory as a snapshot, and data can be refreshed periodically. When you're using direct query mode, data is being retrieved from the data source at the query time. This brings us to important takeaways. Data is not being stored in Power BI itself, so data lives in its original source before, during, and after the query execution. Finally, dual mode represents a combination of previous two options of import mode and direct query mode. That means that data from the table is being loaded into memory, but at the query time, it can be also retrieved directly from the data source. Now, let's talk about import mode in more depth. As we have drawn a big picture previously, let me explain in more detail what Vertipaq does in the background to boost the performance of our Power BI reports. So when we choose import mode for our Power BI tables, Vertipaq will go and perform the following things, the following actions. First, it will go and read the data source and transform data into a columnar structure. Then it will encode and compress data within each of those columns. After that, it will establish dictionary and index for each of the columns. Then it will build and establish relationships. And finally, it will compute all calculated columns and calculated tables and compress them. So how Vertipaq stores the data? As you may recall from the previous part of the presentation, two main characteristics of Vertipaq are that Vertipaq is a columnar in-memory database. So that means that Vertipaq applies different types of compression to each of the columns independently, choosing the optimal compression algorithm based on the values in that specific column. Compression is being achieved by encoding the values within the column, but before we dive deeper into a detailed overview of different encoding types, just keep in mind that this architecture is not exclusively related to Power BI. In the background is a tabular model, which also works under the hood of Analysis Services Tabular and Excel Power Pivot. Now let's go and talk about different encoding types which Vertipaq applies in order to compress the data. There are three different encoding types. First is value encoding, then hash encoding or dictionary encoding, and finally run length encoding or RLE abbreviated. Now we will go into more detail regarding each of these encoding types. Value encoding, this is the most desirable encoding types since it works exclusively with integers and therefore require less memory than, for example, when you're working with text values. How does this look in reality? Let's say we have a column containing a number of phone calls per day, and value in this column goes from 4,000 to 5,000. What the Vertipaq will do is to find the minimum value in this range, which is 4,000 in our example, and set this minimum value as a starting point. Then it will go and calculate the difference between this value and all the other values in the column, and then store this difference as a new value. If you look at this example, we managed to save 3 bits per one row, and at first look, 3 bits, might not look like a significant saving, but just imagine that this table has millions or even billions of rows and multiply this with 3 bits, and I think you will appreciate the amount of memory saved. Next is hash encoding, and this is probably the most frequently used compression type by Vertipaq. Using hash encoding, Vertipaq creates a dictionary of distinct values within one column, and afterward replaces real values with index values from the dictionary. Again, let's take a look at examples. This will be much easier to understand. As you may notice, Vertipaq identified distinct values within the subjects column, built a dictionary by assigning indexes to those values, and finally stored index values as pointers to real values. I assume you are aware that integer values require way less memory space than text, so basically that's the logic behind this type of data compression. Additionally, by being able to build a dictionary for literally any data type, Vertipaq is practically data type independent. And this brings us to another key takeaway. No matter if your column is big integer or text or float data type, from Vertipaq perspective, it's the same. In each case, Vertipaq will create a dictionary for those columns, which implies that all these columns will provide the same performance, both in terms of speed and memory space allocated. Of course, if we assume that there is no big difference between dictionary sizes between those columns. So basically, it's a myth that the data type of the column affects its size within the data model. On the opposite, the number of distinct values within the column, which is known as cardinality, has the most influence on column memory consumption. We will see that later in the demo. Finally, third algorithm, run length encoding or RLE, creates a kind of a mapping table containing ranges of repeating values, and that way avoids to store every single repeated value separately. Again, let's take a look at example, and this will help to better understand this concept. So, as powerful as it might look at first glance, RLE algorithm is highly dependent on the ordering within the column. So if the data is stored in this way, like you see in our example, so I have a complaint value and then many repeating values, then another value again repeating many times, then another value repeating many times. In those situations, in those scenarios, RLE will perform great. However, if your data buckets are smaller or rotate more frequently, then run length encoding would not be an optimal solution. One more thing to keep in mind regarding RLE, in reality, Vertipaq will first perform hash encoding, and then after that it will perform run length encoding. So yeah, the final, let's say the final logic, of course, in most simplified way will look something like this. So run length encoding occurs after hash encoding in those scenarios when Vertipaq thinks that it makes sense to additionally compress the data. So when the data is ordered in that way, that run length encoding would achieve better compression than hash encoding exclusively. So let's quickly reiterate through the process of data compression.
What you just said.
Sorry,
All these three compressing algorithms are done automatically by the Vertipaq engine.
Yeah, exactly.
It chooses which ones to perform on each columns that is in the data.
Exactly.
And optimizes that automatically.
Yeah, that's done automatically. You can use hints to change this and to explicitly tell Vertipaq which algorithm to apply, but I strongly suggest against doing this because in 99.99% of cases Vertipaq knows better than us which algorithm is more optimal for the specific column. So let's go now and iterate through the process of data compression for a specific column, or the process of how Vertipaq thinks. So first, Vertipaq scans a sample of rows from our column. And if the column data type is not an integer, it will look no further and it will use hash encoding. End of story for this part. Now, if the column is of integer data type, some additional parameters are being evaluated. So first, if the number in this sample linearly increase, Vertipaq will assume that this is a primary key column and it will choose value encoding type. If the numbers in this column, in this integer column, are reasonably close to each other, so the number range is not very wide, like in our example that we had with phone calls from 4,000 to 5,000, Vertipaq will also use value encoding. On the other hand, when values in this integer column goes from I don't know, 1,000 to 1 million, then value encoding doesn't make sense and Vertipaq will apply a hash algorithm. However, what can happen? No matter how smart Vertipaq is, it can also make some bad decisions, and those decisions are based on incorrect assumptions. So it can happen that Vertipaq makes a decision about which algorithm to use based on this sample data, but then some outlier pops up and it needs to re-encode the column from scratch. Let's use our previous example for the number of phone calls. And let's say that Vertipaq scanned the sample of this column and choose to apply value encoding because it identified only values between 4,000 and 5,000. Then after processing 10 million rows, all of a sudden it found 500,000 value. It can be an error or whatever. Now what Vertipaq will do, it will reevaluate the choice and it can decide to re-encode the column from scratch using the hash algorithm instead of value encoding. and that will obviously have impact on the whole process in terms of the time needed for reprocessing. Okay, so here is the list of parameters in order of importance that Vertipaq considers when choosing which algorithm to use. First, as already mentioned, number of distinct values in the column, which is known as cardinality. Then data distribution in the column. That means column with many repeating values can be better compressed than one containing values that are frequently changing, because as you already learned, run length encoding can be applied on top of hash encoding. Next, number of rows in the table, and finally column data type, which has an impact only on the dictionary size. Okay, so quickly go through the concept of relationships, because it can also affect your data model size. Once the DAX query has been generated by the formula engine, storage engine jumps in and starts its physical work to satisfy this request. And relationships play a big part in this process. So they enable the quicker transfer of the filter context between related tables. The most important thing to keep in mind regarding relationships is the higher the cardinality of the column that makes part of the relationship, the higher the cost of that relationship is. So when the cardinality of the relationship exceeds 1 million, for example, users can notice slower performance in the report. Okay, so one of the reasonable solutions could be creating pre-aggregated tables with different levels of granularity, so you avoid expensive relationships at the query time. Next, also very important concept for data model size is aggregations. Aggregations are nothing more than reorganized versions of the source table. So you can have multiple different tables related to the same original table. By pre-aggregating data on different levels of granularity, we can help the storage engine to work faster and scan the data in a more efficient way. And applying different aggregations, we are reducing the amount of data, basically reducing the number of rows and columns in our data model. Let me show you a simple example. If you take a look at this example, my raw table contains 7,346 records for chats between July 9th and July 10th, 2017. Now, if I pre-aggregate data and count number of chats per specific subject, my aggregated table will have only 45 rows. So if my users need to analyze data per date and subject, having this kind of prepared table will make the storage engine jobs much easier, and it can retrieve data much faster, of course. One important thing to keep in mind regarding aggregations, they don't have any impact on the optimization of the complex DAX calculations. So they are just enabling the storage engine to work more efficiently and reduce the time needed to execute your queries. Also, aggregations work only with native columns from your data model. In other words, you can't perform aggregations on calculated columns. In reality, to be completely honest, you don't need to apply aggregations on each fact table, of course. With Vertipaq, which works blazingly fast, aggregations make sense only for extremely large tables, for example, a few 100 million rows or a few billion rows. Finally, be careful when you're creating aggregations, as each mistake can prove costly, because if not defined in a proper way, aggregations will produce incorrect results in the report, and we don't want to have this. Okay, so I think we put a solid theoretical background for the things that will come now. And as I promised, we will get our hands dirty and see how all of this works in reality. This demo is based on a real use case which I faced during the last year. The problem was with the size of PBIX file on our report server, and file size has dramatically grown since the report had been originally introduced, and I was involved in trying to find a solution. Just to mention one thing before we proceed, for this demo I've created 4 separate PBIX files, each of them representing one single stage in the data model size optimization. Why I did that? Because we don't need to work on one single file and wait for Power BI to apply all changes we made during the process. As you know, in some cases it takes a while to reload the data and recreate the data model. So let me show you our starting file. I just put simple card visual showing total number of rows in my fact table, so you can just see that data accuracy is not being violated by applying various development steps between those PBX files. I slightly simplified the model for this demo. I have one central fact table which contains data about chats performed by customer support department and two basic dimension tables, dim country and dim product. This fact chat table, let me show you. So it has around 9.3 million rows. Nothing special in terms of volume. So I mean, Power BI should be able to cope with that without any problems. Okay, so to be able to follow what is going on with our data model, I will use DAX Studio. For those of you who are not maybe familiar, DAX Studio is a fantastic free tool created by Darren Gosbell, guy from Australia, and it has a whole bunch of very handy and useful features that we would need another 60-minute session just to talk about DAX Studio. In any case,
We'll
if
do
you're
that.
working, if you're working with Power BI on a day-to-day basis, you should definitely start using DAX Studio. Believe me, it will significantly improve your Power BI development. And that being said, I can connect to DAX Studio directly from Power BI Desktop. Of course, as a prerequisite, you need to have DAX Studio installed on the same machine as your Power BI Desktop. So I'll go to External Tools and launch DAX Studio directly from here. Okay, let's wait a few seconds, and here we are. So first of all, on the left-hand side, I have all of the tables from my data model visible. If you are now curious to know what these strange names are, local date table and then bunch of different characters, we will come to this later. Those are just to let you know in the beginning. So those are hidden date tables, and we will come later to explain why this is happening. One of my favorite features within DAX Studio is Vertipack Analyzer tool, and that will help us to see the numbers behind our data model. So Vertipack Analyzer tool just collects data from various dynamic management views. You can also go and use tool like SQL Server Management Studio and query dynamic management views and get exactly the same data about your data model, but you will probably find it in much more convenient and much more readable way here in Vertipack Analyzer. So if we go to Advanced tab here on the top, here, and click on View Metrics, let's wait a few seconds. And here I can see a whole bunch of different values related to my data model. Let me quickly just introduce some of the most important things here. So we see all of our tables. We see the maximum cardinality of the table size, what kind of encoding type Vertipack applied, and this one is also very useful, percentage of memory that specific table consumes within your data model. Now if we go and click on this small arrow here next to a table name, I can see all those numbers broken down by a column level. And I can immediately spot which columns are the most expensive in data model. So you can see that I have two date columns, date time columns, to be more precise, that goes to a second level of precision. And both have a cardinality of almost 9 million. And both takes, those numbers are in bytes, just to be clear. So both of those columns take around half of gig, so 454 megabytes per column. And you see that it's extremely high dictionary size. You can see that Vertipack applied hash algorithm that we were talking about previously. On those columns, you can see that, for example, on those ID columns, which are primary keys, value encoding type was applied. Now, if I go to Summary tab, let me show you. Total size of my data model is 1.86 gigabytes. So 1.86 gigabytes. I want you to remember this number, as I will refer in the end to this number when I show you how to reduce your data model size. So that's massive. That's really huge, and we didn't even interact with our report. The first step in data model size optimization is to check which columns are necessary for your report, and then get rid of those columns if you're not if you don't need them for building your visualization set for your data analysis. With that in mind, I have those two columns, as I said, date team start, which is the original time when chat started, and date team start UTC, which is basically just conversion to a UTC time. In any scenario, I don't need both of those columns. So I will go back to my Power BI desktop and I will go to Power Query Editor on transform data. Let's wait a few moments just for this to, okay. So it's here, and I will go to fact chat table and get rid of date team start. In any case, if I need to perform some kind of, conversion to different time zones, I can convert within the report itself using UTC time zone. So I will hit close and apply, and let's wait a few seconds for Power BI to apply those changes to data model. Okay, that was fast. Let's go back to DAX Studio. I will click again on View Metrics. And now if I go to Summary tab, you'll see that now the data model size is 1.42 gigabytes. So just by removing one unnecessary column, we reduce the data model size by more than 400 megabytes. Okay, so let's go back to our table and let's check additional columns that are potentially very expensive and can be removed. So as I said, we will leave, for now, we will leave this date start UTC, but other columns like referer and session referer, those are just bunch of JSON records imported as it is. So in any case, if your users need to analyze data on this, they need to be transformed prior to importing them to Power BI. So I will get rid of those two columns. Also, we have two primary keys basically in this table: chat ID, which is the surrogate key from data warehouse, and source ID, which is the primary key from the original source system. I will keep, for now, I will keep chat ID column, and I will get rid of source ID column. So I'll go back to Power BI desktop, and here the most important thing in this phase is to talk to your users and ask them what they really need. So if they don't need to analyze data on some columns, there is no single reason to import them in Power BI. So as I said, I will get rid of referer and session referer. Then I will get rid of which one? Source ID. Okay. Also, source ID. Then also last edit date. This is the information when the record was last time updated in our data warehouse. So it's completely useless for any kind of data analysis. Sorry about that. So source ID, last edit date. Off. I have problems with this. Sorry. Let me check if this. Okay, this is still here. Also chat variables, and I think that's it for now. So let's go and remove those columns, and I will hit close and apply. Let's wait again for a few seconds for Power BI to apply those changes. I'll take a little water while we are waiting. Okay, so we need to wait, I think, maybe around 30 seconds for those changes to be applied to a data model.
I mean, just a recap to my listeners and viewers. It shows that if you are actually importing any column that is unnecessary in your Power BI file, it's costing you so much.
Exactly.
And you always have, and that's the beauty about Power BI. You always have to do a lot of stakeholder engagement to be able to really understand what the stakeholder needs, so that it would be easier on your model, it will be easier on the size, and it will be easier using the vertical engine efficiently.
Exactly.
So it's always important that as Power BI users, especially for developers, those who want to go high level, to always engage the users to know exactly what they want from
Exactly.
your analysis.
Exactly.
Yeah.
Exactly. It's easier to add one or two columns later if the users need it than keep 20 unnecessary columns in data model. So that's the basic logic. You said everything perfect. So nothing to add to this. Okay, so Power BI apply those changes. I will hit again view metrics. And if we go now to summary tab, it's now 660 megabytes. So we started at 8.5 gigs. Now we are at 660 megabytes. So we shrinked 2/3 of our data model size just by removing few unnecessary columns. Honestly, there are more columns here that are, let's say, fishy and could be possibly removed, but we will come later into this. I want to show you uh, other techniques to reduce your data model size. Before I show you, as you said, uh, checking which columns are unnecessary and unused in your reports, checking with your users should always be your starting point when you are performing data model size optimization. Why? Let me show you one very illustrative example. So let's go back shortly to our presentation and let's imagine that you are preparing a delicious dinner for your friends. So you invited your friends for a pizza, but before you make pizza, you have to, of course, to prepare the ingredients. So what goes into a regular pizza? So pizza bread, tomato sauce, ham, cheese. Maybe you need some extra ingredients for some of your guests, such as pineapple or I don't know, corn or egg or olives, because as a good host, you want to satisfy all your guests' needs. Okay, what is the next step? So you're going to do local shop to buy all you need for your perfect pizza. But while you're walking through the shelves in the shop, you see a beer. Do you need a beer for a pizza? I mean, it's always nice to have a beer, but do you need it to make your pizza? No. Few steps more, and you see a nice chocolate ice cream. I like chocolate ice cream. I really do. But again,
Myself.
yeah. But again, do you need it
Yeah.
for my pizza? Oh man, that would be really cool pizza, but really weird pizza. Yeah, with chocolate ice cream on it. So what's the moral of this pizza story? You should focus on those and only those things you really need. Translated to your Power BI development, you should focus only on data your report users really need. You can put something extra, such as pineapples, on top of our pizza in some circumstances when you think that it would bring additional
Right.
value to your report or dashboard, but carefully evaluate if that brings more benefit in the final outcome. Again, would you buy a whole pineapple and put it all over your big pizza if you have only one guest that eat pineapple pizza, or uh, do you maybe prepare smaller pizza for this one pineapple guest instead without disrupting the main pizza? So it's easier sometimes to create a smaller report, translated again to Power BI, with some these specific requirements than bloating your main report with unnecessary thing. Okay, so going back to those columns for removal, but let's say that I want to focus on other techniques. And as you may recall from the previous part of our session, when I was talking about the order of importance of parameters that affect the model size, I mentioned that cardinality is number one. So number of distinct values within the column. The rule of thumb is the higher the cardinality of the column, so the more distinct values in it, it's harder for Vertipack to optimally compress the data, especially if you're not dealing with integer values. There are multiple techniques for reducing the column cardinality, and the most popular one is column splitting. So let me show you a few examples how you can achieve this. First, you can, let me just switch to a proper database. So first you can, for example, using division and modulo operations to reduce the cardinality. How it looks like, I can split the first part of this column with high cardinality in the column with lower cardinality, and in this one Cardinality is also high, but we saved some bits per row, which can have impact on the extremely large data sets. The next one is if you're splitting, if you're dealing with decimal numbers, you can split the values before and after the decimal point, and that will also help reduce the cardinality. And finally, the most common one that I saw is splitting date and time, splitting date time column into separate columns. So here we are keeping only date, and here we are keeping only time portion. That's
Wow.
very useful also for some
Cardinal-
large data models.
Wow.
Uh, Basically, optimization
So,
techniques must be performed on the source side. So in most cases by writing a T-SQL statement or within the Power Query editor. Of course, be careful if you're writing custom T-SQL code to import data in your Power BI data model. Keep in mind that you should perform all necessary transformations, all necessary steps in your T-SQL logic, as the query folding would be broken if you use custom T-SQL query, and afterward apply additional transformation steps in Power Query Editor. Okay, so since we don't have any decimal values in our data model, let's focus on our exact problem, and let's go back to DAX Studio. Our exact problem is this date team start UTC column, which takes almost 68% of our table and 65% of the whole data model. So it's really huge. There are multiple valid options to optimize this column. The first is to check if your users need granularity higher than the day level. In other words, can we remove hours, minutes, and seconds from our data? In 90, I would say 98% of cases, day level of
it will be.
granularity is completely fine. But I made a mistake. I didn't ask my users, and I just remove this time portion here. Let me show you what I got. So first I will close this DAX Studio instance, and this is another PBIX file. I will just show you what I did. In my fact chat table, I just changed type of my data column, so I have exactly the same removed exactly the same columns, and then I just changed type of this column from date time to date. And if I connect to DAX Studio from this PBX file, let me show you how it looks like. We're going to advanced and view metrics. If we go to summary now, it's 230 megabytes. So just
Wow.
recall where we started at 1.8 gigabytes. Now we are at 213 megabytes. So approximately
Okay.
15% from what we started from. And if
So
we go,
actually, Nick, the argument that the data type affects the size or the optimization of the Power BI model is dependent on cardinality, not necessarily the data type.
exactly. Look at this.
Right.
Previously we had date team start column. Let me find it here. Previously, if you remember, we had like 9 million distinct values. So cardinality was almost 9 million. Now we have only 1,356 distinct values. And instead of 450 megabytes, now this column is 9 megabytes.
Wow.
That's the biggest, the biggest savings you can get is by reducing the cardinality, basically. As data can be more optimally compressed. Okay, but as I said, I made a mistake. It appeared that day level grain was not fine enough, and my users needed to analyze figures at least on hour level so they can identify some critical hours, peak hours, and stuff like that. But that could also help me to get rid of minutes and seconds, so I can keep only hours in my data model, and that will also decrease the cardinality of the column. So what I did, let me show you. I've rounded values. Sorry, wrong database. Not tempdb. This one is correct. So what I did, basically, let me show you. I rounded all chats, starting times, to a starting hour. So all chats that started between 3:00:00 and 3:59:59 was rounded to a starting hour, which is 3:00:00. Okay, that's the logic. So we are keeping only on hour level.
Did you
Now,
split the column before, or you just did it inside?
no, I didn't split the column. I just rounded values. So I just used this t-SQL function, date combination of date add and date diff, to round the values to a starting hour. So no splitting column. I kept original column, but just rounding hours, minutes and seconds, yeah, to a starting hour. And here is the Power BI PBIX file that uses this query as a data source. And if we go now to external tools and DAX Studio, let's see how much our data model size has changed. Advanced view metrics. If we go to summary, now it's 221 megabytes. So it's slightly larger than in the previous case, because basically I will show you now. Basically, instead of 1,350 distinct values, now we have 32,000, but still the size of the column is 19 megabytes instead of 454 when we kept original date time portion with minutes and seconds. So it's still fine enough. It didn't increase my data model size significantly, and I fulfilled the request of my users. Okay, going back to table. Yeah, let's check what are the other options. Chat ID column takes almost 1/3 of the whole data model. And as I said, chat ID is just a surrogate key from data warehouse, so it doesn't have any business value. And this column has a cardinality 9.3 million, which is logical as it is a unique identifier of our table. As I said, this column is not used in any of the relationships or calculations within data model. Just to be clear here, and I want you, for your listeners, to come to some quick and incorrect conclusions. We can't simply remove all ID columns. For example, this column, IP address ID, customer ID, user ID, product ID. Those columns are part of the relationships in our data model, but so they can't be removed just like that. But chat ID column is not part of any relationship or calculation. So I asked myself in the end if there would be any benefit if I keep the chat ID column at all. Yeah, let me show you the outcome when I removed the chat ID column. So basically we have again the same number here, and without chat ID column, if I connect to DAX Studio for one last time, if I go to advanced and view metrics, it's 161 megabytes. So just recall where we started. We started at 1.86 and 1.86 gigs, and now we are at 161 megabytes. So I didn't lie when I said that I managed to reduce my data model size by 90%. If you compare our starting point with the current 161 megabytes, I will let you do the math. And one last step, which I promised we will come to, is those tables, hidden date tables. And so we need to disable auto date time options, auto date time in options for our data load. If you're not aware, let's go back to Power BI Desktop. I will talk while showing. So if you're not aware, if you leave this option checked, what Power BI will do, it will create a hidden table for every single date field in your data model. So if you have multiple date fields in a table of hundreds of millions or even billion rows, your data model will be bloated with those hidden date tables. And what is even worse, these tables search for the minimum and maximum date value in that column and automatically create a date range between minimum and maximum value. So if it happens that you have something like December 31st, 2099 for the current records, your automatically created date table will span until that date, even if you don't have any record in your fact table that matches that date. Of course, working with dates and importance of having a proper calendar dimension to handle all time intelligence calculations should be also a topic for a separate session. But I just wanted to give you a quick heads up why you should consider disabling auto date time for your Power BI desktop files. So if I go here to File and Options and Settings, and then go to Options, Data Load, I will uncheck this auto date time option and click OK. Okay, and let's go back. You see that those tables disappeared from here. This is another handy use case of DAX Studio because you can't see these hidden data tables anywhere in Power BI Desktop, but once you connect your data model to DAX Studio, you can see them here on the left-hand side. So let me just one more time check our data model size, and it's 157 megabytes. That's our final data model size. To conclude, I managed to reduce my data model size by almost 90%, applying some simple techniques which enabled Vertipex storage engine to perform more optimal compression of the data, or by simply removing unnecessary columns. And as I said, this was a real use case which I faced during the last year. So you just watching like a documentary about my Power BI work. Maybe some of you now think, wait, Nikola, why did you waste our time with all this blah blah talk about Vertipack and the encoding types and cardinality? What you have just shown us is, yeah, just removal of unnecessary columns, nothing special. And you are not completely, but I would say almost completely right. But I would also say 95% of cases, when you're performing data model size optimization, simple removal of unnecessary and unused columns will be completely enough to get your job done. And as I already said, but it's never enough repeating this, that should be your starting point when dealing with data model size optimization. In those remaining 5% of scenarios, you would maybe need to apply some more advanced approaches, such as cardinality reduction, or using some of those techniques for splitting columns that I showed you a few minutes ago. Okay, going back to a presentation. To conclude, here is the list of general rules you should keep in mind when trying to reduce data model size. Again, first and most important thing, keep only those columns your users need. You already, Ebenezer, you already said that, and I can't agree more with you. Just sticking with this one single rule will save you an unbelievable amount of space, I assure you. As you've just seen in our demo, sticking with this rule helped us to make astonishing savings. Always remember pizza comparison. Next, try to optimize column cardinality whenever possible. There is no single golden rule here. The golden rule here is test, test, test. And if you see a significant benefit from, for example, splitting one column into two, or substituting decimal columns with two whole number columns, then of course do it. But also keep in mind that your measures need to be rewritten to handle those structural changes in order to display expected results in your report. So if your table is not so big, or if you have to rewrite, I don't know, hundreds of measures, maybe it's not worth splitting the column. As I said, it depends on your specific scenario, and you should carefully evaluate which solution makes more sense. Same as for columns, keep only those rows you need. For example, maybe you don't need to import data from the last 10 years, but only 5. That will also reduce your data model size. Again, talk to your users, ask them what they really need before you blindly put everything inside your data model. Aggregate data whenever possible. That means fewer rows, lower cardinality, so all those nice things we are trying to achieve. If you don't need hours, minutes, or seconds level of granularity, simply don't import them. Aggregations in Power BI and generally in tabular model are a very important and wide topic, but there are really some awesome resources on the web. Personally, I strongly recommend reading a blog series on creative aggregations by Phil Simark on dex.tips. Avoid using calculated columns whenever possible. They're not optimally compressed. So if you need to do some calculations, try to push them to a data source like SQL database, for example, or perform them within the Power Query editor. Use proper data types. For example, if your data granularity is on a day level, there is really no need to use date time data type for your columns. In those circumstances, as you saw, plain old data type will be completely fine. And finally, disable auto date time option for data loading. This will remove a bunch of automatically created date tables in the background.
Wow.
That was it from my side. If there are any questions, feel free.
I've really been educated, especially with, I mean, I knew some of these, but like you said, you taking me through taking us through the Vertipack engine has made me appreciate why it's not just about the data types, but cardinality. And also now being able to appreciate what is happening to the Vertipack engine, anything that I do. With the types of encoding, the hash, the value, and the other one was it RE?
Yeah, run length decoding. Yeah.
Yes, all that has helped me shape what is happening behind the scenes as I do any of these queries or any of these additions.
Yeah.
And it has been very insightful, Nikola.
Thanks. Yeah, glad to hear that.
And I hope that users and viewers would take one cue or another from this, especially when you are dealing with large data sets. Check out his blog, datamozart.com, because he's done a lot out there that you would find very insightful. One of the things that I have taken from his Data Mozart, what I use in my training is your NYC, the end-to-end data architecture of Power BI. I use that a lot in my advanced Power BI classes to show people how you can do actually end-to-end architecture.
Yeah, that's great to hear.
I'm very grateful for your time, Nikola. Nikola is a Microsoft MVP. He works with Avanade, one of Microsoft's subsidiaries with Accenture, and they are one of the world's leading digital transformation solution company, and they are heavy on business intelligence. No wonder they've managed to get Nikola in there. So, Nikola, thank you so much for your time, and viewers, catch you another time. Nikola promises to do another interview on the 7 magnificent tricks, hopefully very soon. I hope to do that and upload also that very soon. And thank you very much. Hopefully Barcelona gets better.
And thanks, mate. Thanks for having me. And yeah, I promise we will do another session on tips and tricks.
All right. So stay tuned. And I would also want to announce my viewers that I have a new website coming on. It's called eurekabi.com. And finally, I've brought out a product that I'll be sharing with you over time. But thank you very much, Nikola, and stay tuned to the channel. Bye.
Bye-bye. Ciao. Thank you.